Hi, you're listening to Ice World Podcasts. I'm your host, Rob Taylor. Today I'm sitting with two scientists who've just come back from Pine Island, where they've been on a drilling project with Rob Mulvaney. Isobel Dieter, welcome to the show.
Thanks for having us.
So what are your specialisations? What do you guys both study? What's your work at home?
So I would say that we are part of ice core research. So we look at paleoclimate and we use ice cores as our archive to investigate past climate.
And do you have specialisations within that?
Yeah, so I look at quite long-term climate. So I'm looking at sort of glacial cycles, so glacial scale time scales. So that's sort of on the scale of hundreds of thousands of years, and specifically I'm focusing in on the last glacial cycle. So that's from the last 115,000 years.
I looked at the recent climate change here in Antarctica, so that means, let's say, the last 500 to 300. Everything that has happened in the last centuries here around the Antarctic Peninsula.
So I attended a science talk you guys did maybe 3 days ago, and I was blown away by the amount of information that you can get from a chip of ice. So talk us through the process. You've taken some ice, it's from say 200, 150 metres down. What do you analyse first, and what does it then tell us about climate then and now?
So depending on the research questions that you're hoping to answer, you would look at different components within the ice. But generally speaking, the first thing most people tend to look at is water isotopes. So you take a measurement of the water isotopes inside the ice, which can inform us about past temperature. Then from there you would start to investigate other parameters. So you might start to measure chemical parameters, which can give us an idea of the age within the ice, or can give us an idea of, so some chemicals fluctuate annually, so that can help us to date the ice. And then if you were interested in the greenhouse gas record or the gas record in the ice, then you might start to look at what's contained within the ice bubbles themselves.
Just to add a little bit to that, when we get the ice back in the lab, we first measure, before doing all the chemistry, we measure density of the ice. And then we also measure physical properties. So then before we actually melt the ice and get the chemistry, we kind of measure like how the electricity is being conducted by the ice. And that can also give us like a second round of information like out of the chemistry, which sometimes
that's the dielectric.
Yeah, the dielectric.
What can that tell us?
So sometimes, let's say some layers of ice from some seasons, they contain more salts. So then, as the ice itself contains more salts, then it transfers the electricity kind of in a different way. So then, also sometimes whenever you have like a volcanic eruption, then you also get like sulfates in the ice. So then those sulfates help to conduct more the electricity. So then you have like an independent way from the chemistry to also get some information.
Some of what you've just said I was aware of before, from speaking to Rob Mulvaney and from kind of public knowledge of ice core science. But one thing that surprised me was how you guys are studying winds, so historic winds, with regards to climate change and the melting of ice. Could you tell us a bit about the methodology for that and how you go about that?
Yeah, so studying about the winds, it has been like a bit like thrown away from the main studies. Let's say first it was the idea of measuring the temperature, because it's something that we are really aware that is changing, also the gases and everything. But recently, out of getting all this information, then there's one parameter that we don't understand pretty well, which is the winds. Most of the times people talk about the winds as something that you really can't measure, because whenever you're in a windy place, then you have like gusts. Then sometimes you have like kind of the directions changing one to another. But in the long term, like winds can really tell you a lot of information. So apparently the winds are the ones that are bringing all the heat from the tropics and from the mid-latitudes towards this region, and they're affecting the sea ice extension. So the sea ice is retreating because of all that heat that is coming. Then as the winds are bringing more heat, then we're increasing the atmospheric temperature here. Then, and so on, different parameters. So the methodology that I'm developing now for my research is studying phytoplankton in the ice. So the phytoplankton, they live in aquatic environments. So when you have a sample of ice, this ice is taken from very far from the ocean, let's say from the open ocean. So then there's a reason why this kind of liquid environment, phytoplankton gets to the top of the ice sheet, and the idea is that the winds are being able to remove that phytoplankton, and this phytoplankton travels on the atmosphere and then it gets deposited on the ice sheet. So the more phytoplankton you get on top of the ice sheet, it's a kind of measuring, like what we say, a proxy of stronger winds. So the stronger the winds, the more diatoms you get on top of the ice sheet.
So the concentration of diatoms that you get is really directly proportional then to the wind that was prevailing at the time.
Yes, that is one of the latest results of my research. So the more diatoms, the larger the amount of diatoms that you get in a certain amount of period. In a certain period, the stronger the winds in some regions of Antarctica. It's not everywhere. It's mostly positioned in the Southern Ocean, mostly in the Amundsen and Bellinghausen Sea.
So you guys went drilling at Pine Island. How long were you there for?
So we were there for 2 weeks in total.
And how was that, camping out on the ice and drilling every day?
Yeah, it was a great experience. The drilling went really, really well up until the point that unfortunately it didn't. But we got into a nice routine. So we were using a new drill called a rapid access isotope drill, which instead of taking a solid ice core, drills very rapidly, but it only brings back ice chippings. So obviously, as you can probably tell from the name, the main aim of this is so that you can get an isotope record from the site where you're drilling. So that gives us a rough indication of past climate through temperature, and we can then, because we can get it so quickly, that's what makes this technology so valuable.
Okay, so get down, get the crushed ice, and then for what you're looking at, it doesn't matter that it's crushed, it's fine.
Yeah, because we're mainly just looking at the isotope record. We can try and get some chemical parameters from that, but because of the way that it's drilled, so it comes up in these chippings, there's going to be contamination there, so you can't really rely heavily on a chemical record from that.
Okay, and did you choose Pine Island, or did that just happen to be where drilling was happening this season?
So there was a number of sites, so the main emphasis for this project, so the motivation for this project is part of a larger project called Waxwane, which is investigating the climate stability of the West Antarctic ice sheet during the last interglacial period, so before the last ice age when it was actually a little bit warmer than it is today. And the basis for that is that represents a good investigation for what could happen in the future. So whether or not, we're trying to find out whether or not the West Antarctic ice sheet collapsed during that time, or to what extent we think it collapsed during that time. So there's already been another core drilled from a different site called Skytrain Ice Rise, and then this year we were heading out to Sherman Island, where we predicted that sort of some flyovers from in the past had indicated that there was ice possibly deep enough to reach to the last interglacial, and because it's in this rain shadow effect from Thurston Island, that the accumulation levels were low enough that we would be able to reach back to that time period as well.
So how long ago would that ice have formed?
Well, so the last interglacial was 130,000 years ago.
Wow, that's really ancient.
Yeah, very old.
That's quite cool.
Yeah, very exciting.
So you were there for 2 weeks. The drilling went fine, and then what happened?
Yeah, so the drilling was all going okay. We were at about 320 metres, and the drill went down as usual. Everything seemed to be going fine, no indication of anything going wrong on the way down. The drill hit the bottom of the borehole, so the depth to which it had previously reached on the previous drop. And so Rob, our supervisor, who was kind of in charge of the drilling, raised the drill up a little bit to start the drill, and it didn't come back up, so it just got jammed there, and we don't really know exactly what happened to it. We made some attempts to try and free it, but none of them were successful, so unfortunately the drill is still there at 323 metres.
Right. And do you think, will you come back to Antarctica again? Do you have more field work that you'd like to do here?
If I ever got the opportunity to come back, I would definitely take it.
Yeah, you've both enjoyed it?
Yeah, both.
But there are no immediate plans.
Okay. So is it a case of head home now and well, you're going to go on a bit of a holiday first, but then analyse your results?
Pretty much. So the ice will come back later in the summer, and then it will be months of analysis and spending time in the lab to figure out our results. Yeah. Excellent.
Well, I'm looking forward to having a read of your paper when you guys finish that off.
Maybe in a year time.
Yeah, I can wait. I'm here for some time.
Plenty of time for reading out here.
Well, thank you both for coming on the show. It's been good having you.
Thank you.
You've been listening to Ice World Podcast, a podcast on behalf of the British Antarctic Survey.